All right, we're moving on now to taking those sequences and seeing how we can put those into tables and write a variable expression so that we don't have to just constantly add the 2 or add the 3 or whatever to the previous term to get the next term. Because if we want to know like the 100th term or one that's quite a ways down the road, we don't want to have to sit there and keep counting. We can come up with an expression so that we can solve pretty quickly and easily just by multiplication. Okay, so just to kind of get us thinking on the right track here, we've got a car here. It tells us what it gets per miles per gallon, and so we're just wanting to complete the table on how much it's or how far we can go on 4 and 5 gallons. So here, what they've done is they say, okay, 1 times 18.1 is 18. Okay, 1 times 18.1 is 18. 2 times 18.1 is 36.2. And 3 times 18.1 is 54.3. So what we're doing is we're adding that 18.1 to each time. So now to find the fourth term, or how far I can go for 4 gallons, it would be that 54.3 plus 18. So this would equal 54.3 plus 18.1, which is going to equal 72.4. Okay, likewise 5 gallons now, that's going to be 72.4 plus 18.1, which is going to equal 90.5. Okay, so that's one way to do it. But now if we wanted to know how much is going to go in 10 gallons, if we can find what the equation is, and it kind of lays it out for us right here. And another way to think of this is proportional constant, or constant proportionality, K, equals Ry divided by X. So if you took this is our y and this is our x, and you divided our y by our x, each time we're going to get 18.1. That's going to tell us what our k value is, or what we're going to be multiplying our term number by. And so we can just write 18.1 times n. N is this is going to represent our term number. Okay, so we could have also set this as 18.1 18.1 times 4, our term number, equals 72.4. And same thing with 5 gallons. So that's kind of what we're going to be looking at. We're going to write that variable expression by finding what that common term or that common difference is. Okay. So now in these tables, you'll notice that our term number is not sequential. So it's not 1, 2, 3, 4, 5, and so on. There's gaps here. And so we're going to need to find out what that changes. And these luckily are proportional graphs. So we can go 18 divided by 1 equals 18. 72 divided by 4 equals 18. 216 divided by 12 equals 18. So this gives us right here that multiple, that term that we want to multiply by to get our term. So we could set this up as our term number is equal to 18 times n being our term number. So in this case, if we want to find what p is, well, p is our 7th term, so this isn't term number, this should be value. We want to find out what our value is. it is 18 times n, which is our term number. So to find our value for p, so p equals 18 times 7. And when you take 18 times 7, you'll get p is equal to 126. Okay, likewise, now we want to find what q is, but q is now the term number, so still the same, except our value is 270. We're still going to multiply by 18, and we're just multiplying 18 by q. Okay, but we want to solve for the variable q, so we have to steps for solving a one-step equation. Divide both sides by 18, and what we'll be left with is that q equals, this is 15. So q equals 15. Okay, so now the last part, it wants us to write this variable expression. So that's just going to be this 18, what we're continuing to increase by, times our variable n. So that's our variable expression. Okay, so now let's do the same thing with this next table. First, we want to find out, is there a constant number that we get when we divide our value by our term number? So let's go 66 divided by 3, which equals 22. 110 divided by 5 equals 22. 198 divided by 9 equals 22. So this is proportional. This gives us that constant number that we're going to be multiplying the term number by to get our x value, or to get our value for whatever term we're looking for. So now we can set this up as value equals 22 times n. N once again is representing the term number. Okay, so now we want to find out what x is. It gives us our value, so 132 equals 22 times x. We want to solve for our unknown or our variable, so we always get it by itself by dividing both sides by the coefficient. This will leave us with x is equal to 132 divided by 22 is going to give us 6. Okay, likewise, we're going to use the same equation to solve for y, but this time y is our value. We're going to multiply by that number, the 22, which is the constant increase, and then we're going to multiply that by 11. And there we'll find out that y equals 242. Okay, so then the variable expression, that's just going to be 22n. So if we want to find what the 10th term is, we just take 22 times n. So this is our variable expression. Okay, so these were tables where they weren't sequential again for our n value or our term number. The next ones we're going to be looking at, we are going to find that that's going to be true, which makes it a little bit nicer in determining what that constant change is. Okay, so we want to write a variable expression and find the 100th term on this one. And so the table they've already set up, so they've put each one of our values already in the table here. And then the term number is just 1 through 4, and then would carry on to, they use n to represent the term number when we're not given the specific number. Okay, so it shows right here, this is the number that they continue to increase by, or you're adding 8 to each one here, plus 8, plus 8. So what it is you're multiplying that term number by 8. So to write the variable expression, you just take what that constant increase is, or decrease, and you're going to just multiply it by your n term. And that's what you can use to find whatever term you want. So now if we want to find the 100th term, we just take n times 100, and that gives us 800. So the 100th term of this sequence up here is going to be 800. Okay, this one was fairly nice because it is a proportional relationship. These next two are not proportional, so there's going to be an additional step here. All right, but what we're going to do is we're going to put our sequence here. This is our 5 is our first term, 8 is our second, 11 is our third, and 14 is our fourth. Okay, so what you'll notice is that this is an increase of 3. So we're going to use this to write our variable expression. So that constant change, or what the constant increase, which is the plus 3, that's going to go in front of our variable n. Okay, so that would be our variable expression. However, if we put 1 in for n, we don't get 5. And if we put 2 in for n, we don't get 8. So what we're going to have to do is say there is something that we need to add to this. And in the way we find that, we're going to set this equal to 5. And then plug in 1 for n. So this would be 5 equals 3 times 1 plus b. So this is going to give us 5 equals 3 plus b. One-step equation, we want to solve for b, so we're going to minus 3 from both sides. And so we'll see that b is equal to 2. So now we're going to add this into our equation. It's going to be 3n plus 2. So now when we take our term number 1 for n, we get 3 plus 2, which does equal 5, which gives us our first value here. So this would be our variable expression. Now it asks us to find our 12th term, so we're just going to do 3 times 12. So we plug in 12 for our term number plus 2. This is going to be 36 plus 2, which equals 38. And so there we've found our 12th term. Okay, so next thing, so same thing. We're going to set this sequence up the same way. Find what that constant increase is or decrease, and then use that as our multiplier for our variable expression. So we've got first term, which is 15. Second term is 11. Third term is 7. Fourth term is 3. And what we'll notice is this is a decrease of 4. So 15 minus 4 gives us 11. 11 minus 4 gives us 7, and so on. So we're going to use this term for our variable expression. So it'd be negative 4n. Okay, now once again, if we put 1 in for n, we get negative 4, which is not 15. So we're going to have to once again add a value to make it true. So I'm going to put 15 is equal to negative 4n plus b. And then we're just going to put in our 1 for n. So I'm just going to erase that 1. Okay, which is just 4. So to find b, we've got to get rid of this minus 4. So we're going to add 4 to both sides. And what we'll get is 19 over here, and that is equal to b. Okay, so now our variable expression is going to be negative 4n plus 19. So now we've substitute our value for b, n, and that gives us our variable expression. Now if you put 1 in for n, negative 4 times 1 is negative 4 plus 19 is going to give us 15. Okay, last step, we want to find the 12th term. So that would be negative 4 times 12 plus 19, and that is going to equal, so negative 4 times 12 is negative 48, plus 19 is going to give us, or 48 minus 20 would be, negative 48 plus 20 would give us negative 28, and we're just going to add 1 to that, so it's negative negative 29. And there we have our 12th term. And that's what you're going to be doing with sequences, finding a given term, writing your variable expression for them, or maybe filling out